All right, so I have some examples here for you. It's to tell whether a relation is a function or not. And we have several different examples of it. So, for example, number 3 talks about a set of coordinates. Okay. Number 4 and number 5 are tables, and 6, 7, 8, and 9 are graphs. So what we're going to do is we're going to take one at a time and we're going to go through them. So a function, the definition is when you have, for every one input, you have only one output. So for example, in this, we have the inputs, which are the x's, and that's an x, and that's an x. And this is an x, and this is an x, and that's an x, and then this is y, y, y. So the x's are the inputs and the y's are the outputs. So you can see that on the second ordered pair and the third ordered pair, it has the same input, the same x value. But you can see that their y values are different. Well, that means this is not a function. This is not a function, because it has the same input, but it has two different outputs. So this is very similar to that function machine that we started off the very beginning of the year in September. I had put a function machine on the board, and I said, okay, so now there's a rule hidden inside this machine, and I'm going to take a number and I'm going to put it in the machine, and let's say I put 5 in the machine and out comes 8. Then I put 6 in the machine and out comes 9. Okay. And all of you said, okay, well, I know the rule is to add 3 to whatever number I'm putting in. So that means if I go back to 5, if I put it in again, all of a sudden it's not going to come out 50. That wouldn't work. If I'm putting an input in, it's going to come out the same way every single time. So here, when I'm putting a 0 in, out comes a 1. But here, when I'm putting a 0 in, out comes a 4. Well, that's not possible. And if it's not possible, that means it's not a function. So let's take a look at the next one. Now, the next one is the same exact thing. It's just in table form rather than a set of ordered pairs. So what we're going to do is we're going to look at the inputs. And I see 2, I see 6, I see 1, I see -1. Well, none of the inputs are the same. So it doesn't matter what the outputs are, because if none of the inputs are the same, you can have 2 different inputs having the same output. So yes, this is a function. So this is a function. Now let's take a look at the number 5, the table. Well, the input is -1, 0, 3, and 3. Well, wait a minute. There are 2 3s. But when I put this 3 in, I get a 0 out. And when I put this 3 in, I get a 1 out. Well, you can't have the same input and 2 different outputs. So this is not a function. Now, there's been something that I've always said. One of the ways that I teach this, and I'm going to give this to you. Maybe this helps. Maybe it doesn't. But what I'm going to do is let's see where I can put this. I'll put this over here. Okay, so now the input, which is on the left, which is the X, is going to be a person. And the output, which is the Y, is going to be a birthday. So let's say Bob, and I'll put him as a B. Bob was born on the 8th, let's say the 4th. Okay. Now Jill can also be born on the 4th. So that's where we get that 2 different inputs can have the same output. You can have 2 different people born on the same day. I mean, that happens all the time. But suppose we had Jill again, and Jill also has the 6. Well, wait a minute. You can't have Jill having 2 different birthdays. So that's where we say that these 2 same inputs, Jill, can't have the same birth can't have 2 different birthdays. And so this would not be a function. And maybe that helps. So you can have 2 people sharing a birthday, the same birthday, so 2 inputs having the same output, but you can't have one person having 2 different birthdays. Okay, so let's take a look at the picture, but I'm going to fill this in first just for a few notes. So it says, when given a graph or picture of a relationship or a relation and ask if it was a function, the vertical line test is used. This test helps you to know a relation is a function by looking to see if any vertical, and vertical meaning up and down line, drawn does not intersect the graph at more than one point. In other words, on a graph, each x value is paired with only one y value. And this is the very same thing that we've been talking about. The input can only have one specific output. Okay, so we're going to use the vertical line test for these. And if I put a vertical line, I can put a vertical line anywhere I want. So let me put one there. Do you see how it only hits one point of that line? Let me do this one. Okay, do you see how that only hits one point of that line? Let me do this one. And you see, I could put a number of lines so that every single time it will only hit one point of that line. So let me try it with 7, and I'll just change the color so that you can see a little bit better. So that only hits one point, that vertical up and down line. But let me try this. Well, do you see how that goes through 2 points? So when this one over here only hit 1 point, this is a function. But this one is not a function because it hits 2 points on that line. And the thing about this is, if I take a look at those 2 points and put down what their coordinate, what the ordered pair is, this would be -2, +2. So this would be -2, +2. But this one down here would be -2, -3. You see how they have both the same inputs, but their outputs are different, which means it can't be a function. So let's take a look. And that's why the vertical line test works, because basically what it's doing is it's showing you these 2 points have the same input. They're both at -2 on the x-axis, but they have different points, different places on the y. And so let me take a look here. Well, look, right off the bat, I know that this is not a function, because when I put that vertical line through this shape, what happens is it hits 2 places on there. Okay, so let me do one more. And well, that only hit one place. And that only hits one place. And that only hits one place. And it doesn't matter where I put the line in this. This is a function. Okay, so that's how you do that with ordered pairs, tables, and graphs. And that's what I'm going to ask you to do today.